All right. Hey, everyone. So this is lesson 9, right? I don't think I did such a good job cutting and pasting all this stuff in. Oh, I remember. It's up here. And yeah, it's lesson 9. So in lesson 9, we're going to be evaluating these sum and difference expressions, but we're going to be evaluating them at just kind of arbitrary angles. It says S and T. And you don't know much about S and T. They're certainly not unit circle values. What you know about S and T is only what they tell you. And they're always going to tell you two things. They're going to tell you the value of one trig function at S, and they're going to tell you what quadrant S falls in. And that's good enough. That those two things actually allow you to figure out everything else you could possibly need, because if you know the one trig expression, and if you know the cotangent is x over y, then you can figure out real quick that if we're x over y, then x is 1, y is 5. And I'm actually at the moment not really sure who gets the negative sign. Is it -1 with positive 5, or is it positive 1 with -5? And well, that's where the quadrant comes in. It says right here that we're bigger than pi over 2, which don't forget is 90. And it says we're less than pi, which is 180. So that's just a fancy way of telling you that your angle lives here in quadrant 2. And that answers our question. We know that in quadrant 2 we have a negative x with a positive y. So the x will be negative, the 5 will be positive. And to find z is just Pythagorean Theorem, which we would normally say is a squared plus b squared equals c squared. But for our purposes, we're really saying the x coordinate plus the y coordinate equals the radius squared. So we're plugging in. We get a -1 squared, 5 squared equals r squared. That seems to imply that r squared is 26. So you take the square root, and technically you get plus or minus root 26. But the radius can never be negative. So this negative solution, that's extraneous, throw it out. Our radius is, or our z value, our radius, sorry, root 26. So no, it's not z. It's the radius. We're supposed to be finding x, y, and r, of course. Okay, but there you go. We did it. We know that for angle S, we're living in quadrant 2. The x coordinate, the y coordinate, and the radius of the circle that we're living on are -1, 5, and 26, root 26. So the deal is you just now have to do the exact same thing for angle T. So again, they've given us one trig value at T, and we could use that to find the rest. And they've also given us the quadrant that contains T. So it's sort of like, all right, back to the drawing board. I need to figure out x, y, and r for this angle. And again, angle T has us in quadrant 2. Yeah, we're still in quadrant 2 for angle T. Sine is y over r. So that tells me that my radius is 5, and the radius can't be negative. It tells me that my y is 3. And it's got to be positive, because if it was negative, would get a negative sign value. So what about the x? This time around, you should recognize a 3, 4, 5 Pythagorean triple. You should know right away that x is 4, but it might be -4. You got to go back and think about the quadrant, and lo and behold, since we're in quadrant 2, we should be expecting a negative x value to go with our positive y values. But that's it. This one was actually a little easier. We've got our x, y, and r. So now what the heck is it we're actually doing? Well, remember up here, we were trying to find cosine of s plus t. So take that expression and expand it. You're going to want to be doing cosine of s times the cosine of t. And you're going to want to be subtracting from that the sine of s and the sine of t. So here's the deal. We need the cosine of s. Well, we conveniently have all the data on s right here. Cosine wants to be x over r. So it'll be -1 over root 26. There. Now we also need the cosine of t, and we've got all the information over here about angle t. So cosine is still x over r, so it'll be -4/5. Now we need the sine of s. So, okay, hop back to the data on s. Sine is y over r, so that'll be 5 over root 26. And then the sine of t, well, actually, sine of t was a freebie. They gave us that, it's 3/5. So there you go. So let me make some room, and we'll actually do that calculation now. Tired. Alright, first of all, this is the expression I'm trying to evaluate. Second of all, we weren't really supposed to leave radicals in our denominator, so let's rationalize those. So taking this purple expression and bringing it down, this would be negative root 26 over normal 26 times -4/5 minus 5 root 26 over 26 times 3/5. And we're multiplying, so this negative times a negative will be a positive, and we'll get 4 root 26. And just because I'm running out of space, that will be in my numerator, but I'll have this shared common denominator, that is whatever 26 times 5 is, so sounds like 130 to me. We're now subtracting 5 root 26 times 3, so that's 15 root 26. And now, since both of the terms of the numerator involve root 26, they are like terms, and so you do just subtract the coefficients, and 4 minus 15 will be -11 root 26, all over 130. I do believe that should be our answer. Whoopsie daisy. Okay, so there. Yeah, sure. I'll show you a way that you can double check your math. See if you guys like it. So, here's a calculator. And it doesn't cover the face. I don't know where to put it. Can shrink it a little. Put it here. Maybe that'll work. Okay, so there. Move my dumb face over to there. Okay, whatever. Ah, my bad. Okay, I guess I'm ready. So what am I showing you? I was trying to show you how to double check your work. Well, here's how you double check your work. It says right here that, I'm not pointing at anything, it says right here, oh no, you can't see my pen anyway? Hold on. What do you see now? Now I think you see it. Okay, it says right here that the cotangent of s is -1/5. That would mean that the tangent of s is -5 over 1, right? Well, we've got scientific calculators, so let's hit the buttons. We can actually just do the inverse tangent of -5, and that's going to actually give us the measure of angle s. I'm in radian mode. I'd rather be in degree mode for this, I think. So back to degree mode, do the calculation again. Apparently it's a -78-degree angle, at which point I hope you all say, no it isn't, Mr. F, because it says right here, that our angle is actually supposed to be living in quadrant 2, right? So let's see if you guys follow this. Well, the angle that I was given, that negative 78, that's a 78.69 degree reference angle, right? So if I wanted to port this thing back over into quadrant 2, wouldn't I just want 180 minus the 78 point blah blah blah? So technically I guess I just add on the answer, and I get 101, right? 101 would be the quadrant 2 angle that has the same reference angle as the thing I just did. So that, by the way, is now S. I will store it in my calculator as, you guessed it, S. There, I now know what angle S is. I have it. Okay, clear that out. Now let's do it again, but this time for t. So we knew that the sine of t was 3/5, so this is what's stopping me from going inverse sine of 3/5. Hitting enter. Now for sine, I get a quadrant 1 angle, which again, you guys are saying, excuse me, Mr. F, we're supposed to be in quadrant 2. So do the same thing. That's the correct reference angle. It's just not in the correct quadrant. So to get the correct angle in the correct quadrant, and we're in quadrant 2 again, so again, we'll go 180 minus that angle I just got. And now apparently t is that angle, 143 blah blah blah. I shall store that as, you guessed it, t, right there. Okay, great. Now that I have that, guess what I can do? I can now just ask my calculator for the cosine of s plus t, which is literally what it says on the paper. Cosine of s plus t should be, boop, that. And what did we get? We said the answer was negative 11 divided by root 26. I don't know why I just said that. 11 times root 26. And then that whole thing divided by 130. Would you look at that? That's definitely the right answer. So again, everything I just showed you, you can't replicate this during the quiz because you won't have a graphing calculator. But maybe this gives you some sense of what the heck's actually going on here. Like, there is some angle that S is. Like, we could find out what angle S is if we wanted to. And we did. We actually know that angle S is some 101.31 degree angle. It's living in quadrant 2, right? None of that's actually important, though. You don't need to do that to solve the problem. What else do we know? We know that T is a 143 degree angle. So when they ask you to evaluate the cosine of S plus T, you're just literally doing the cosine of, like, 244-ish, right? You're basically just doing the cosine of 244. You're going to get some answer. Anyway, again, I think this is another one of my, tangents that's not super helpful, but it's still stuff that I think you guys ought to know. And hey, it's good news to know that we also got this question right. It's definitely negative 11 root 26 over 130. But this wasn't even a homework problem, so I will now get into the homework problems 13 minutes later. All right, that's not homework. That's a try your own. This is homework. Never mind the fact that it says classwork. But I told you to do the odds, so I'll stick with odds. I don't see anything special about this. Seems very similar. So we'll leave 1. If anybody wants to do 1, they can. But I'm going to talk about 2. Unless we did 2 in class, which I think we kind of did across the board. But I'm going to do it anyway, because it's a homework problem. And some of y'all don't bother to write anything down during class. I should probably point out immediately that there is a typo. It's right here, where it says that angle B lies between 0 and 2 pi. That's incredibly not useful to be told that B is some angle that lives anywhere here. It's literally anywhere on the unit circle. So that's a typo, and we meant to tell you that B goes from 3 pi over 2 to 2 pi. So it's in quadrant 4 is what we meant to say. So make that change so that you'll know that you're just living in quadrant 4. So this limit here should be 3 pi over 2. Alright, so what else do we know? We know the secant of B is that. And we know tangent of A is that. And what are we actually doing for number 2? Looks like I clipped that off. Yeah, so I better pause the video and double check what it is we're actually doing. Although my heart says it's going to be the tangent and cotangent one, but I'm not sure. I'm not certain. Best fit. Okay, so let me double check. Okay, I just checked it. Number 2 is doing the same thing as number 1. It's the cosine again. Cosine of the sum, cosine of the difference. Whoops. So that's fine. That's what we'll do. Okay. Yeah. Yeah, that's what we'll do. Okay. So we haven't done anything. I thought we had done something by now, but we haven't. So we need to use this given information to find our x's, y's, and r's so that we can find our sines and cosines. So let's do it. I'll throw this in the garbage. I'll do this one a little more quickly and probably a lot more informally, and hopefully that'll be okay with everybody. So for A, again, another typo. This should be capital A. But we know that for angle A, we have as an x and a y and an r. They gave us tangent. Tangent's y over x. So the y is 8 and the x is 15. And as far as who's negative, it depends on what quadrant we're in. But if we're between 90 and 180, then again we're in quadrant 2. And in quadrant 2, x's are negative, y's are positive. And I'm also recognizing 8 and 15 as a Pythagorean triple. This is the 8, 15, 17 Pythagorean triple. Just to remind anyone, if you don't actually memorize your triples, then of course you can still just do the Pythagorean Theorem. So you're going 8 squared, 15 squared, solving for radius squared. So 64 plus 225 is 289. And square root of 289 is in fact 17. So you can definitely find that the radius is 17 without remembering your Pythagorean triples, but it takes extra work. But you will have a calculator, so it's not so bad. I'm going to take all that work, shrink it. We won't throw it in the garbage bin, but we'll put it over in the corner. This is all I need, huh? That's all I need. Because I know now that when I go to expand this cosine, I'm going to get cosine of A. So this is a typo again, jeez. This shouldn't say alpha and beta because we're given A and B. So this should be A, regular old American A, American A. Listen to me. English A and B. All right, where am I? What I was trying to say was, now that we've got these, we know that for this expansion we're going to need the cosine of A, and we know it now. Cosine of A is going to be x over r, so negative 15/17. And we're going to need sine of A, and that's going to be the 8/17, positive 8/17. So we've got what we need out of angle A, so let's head over to angle B. Angle B is a secant, so right away I'll probably just rewrite that as a cosine of B equaling 4/5. By the way, that's one of the things I need. I'm going to need the cosine of B, and it's 4/5. But I'm also going to need the sine of B. So to find that, we do our x, y, r. Knowing cosine means that we know x and r. So x is 4, r is 5. And again, what quadrant are we in? We're in quadrant 4. So does it make sense that x is positive? Sure it does. Quadrant 4 is over here to the right. But we can see that our y value will be negative, and our y value by Pythagorean triple will be 3. It'll be negative 3. So the sine will be negative 3/5. So now we really have everything we need to find the cosine of A plus B. You know the expansion is going to be cosine A times cosine B. With a plus sign, we'll go to minus. It'll be sine A sine B. And then we're just substituting. Cosine of A, we just said, would be the negative 15/17. Cosine B is the 4/5 from over there. These are getting multiplied. Sine A is the sine from over here, 8/17. And sine of B is negative 3/5. So the biggest thing that's going to go wrong here is someone's going to just lose a negative sign. So make sure you're really careful. Make sure you're thinking about how A is a quadrant 2 angle. So does it make sense for cosine to be negative? Yes, because it's to the left. Does it make sense for sine to be positive? Yes, because quadrant 2 is up. And then angle B is a 4th quadrant angle. So does it make sense for cosine to be positive? Yes, because the 4th quadrant is to the right. And we do need to make sure that sine of B is negative because quadrant 4 is down. But I've got all my ducks in a row, it seems. So now just do the math. And when you're multiplying these here fractions, you don't need a common denominator. You just multiply the numerators. We're going to get negative 60 here. And you just multiply the denominators. So 17 times 5 is 85. Now, in the numerator, we get negative 24. In the denominator, we get 85. So now to arrive at our final answer, we do need a common denominator, but we already have one. We've got the 85. So just remember, if we're subtracting a negative, then we're actually adding. So I basically want to take 24 away from 60, 36. That feels right. So it'll be negative 36 over 85. And that should be the correct answer. Yeah, you know what? I'm going to show you again how to check your work on the graphing calculator. Again, just fast forward if this is not something you feel like seeing. So TI calculator. Bring to the front. Update view screen. All right, there it is. So again, how do we cheat? Well, what we do is we figure out the actual value of A by doing the inverse tangent of negative 8/15. Inverse tangent, negative 8/15. Again, that's going to return a negative angle, but we're trying to be in quadrant 2. So let's just add 180 to that. And then there's my quadrant 2 angle that has this tangent value. So I'm going to go ahead and store that as alpha A. Boop. So that's A, stored. Now for B, we had secant of B as 5/4, but I don't have a secant button. So we turn that into cosine of 4/5. So if we go inverse cosine of the 4/5, we'll get a quadrant 1 angle, but we wanted a quadrant 4 angle, remember? Because we're supposed to be over there. So I guess that means we do 360 minus that angle. And that would be our quadrant 4 angle that has the correct value of cosine. So I'll store that as B. Again, by the way, just to keep kind of demonstrating, if I did cosine of B, that should give me 4/5. And look, I get 0.8. 0.8 is 4/5. So I'm literally solving for the angles so that now I can check my answer. They wanted me to do cosine of A plus B. So okay, sure. I'll literally do cosine of A plus B. And it says it's this. Now what did we say the answer was? Negative 36/85. Boop. Would you look at that? That's kind of satisfying, right? To know that that fraction that we just got is the right answer. That is the exact value of the cosine of these two technically unknown angles. So there, we did it. Of course, that's not the end of the line. So let's bring you out of here. Yoink. So that's gone. Remember, you were asked to find two things. You were also asked to find the cosine of a minus b. But if you've been paying attention at all, then you know that the cosine of a minus b is going to be all the same stuff, except the sign in the middle will be a plus sign instead. So we can maybe just shoot over here and say that the cosine of a minus b is going to be this exact same expansion, just with a plus sign in the middle. So it'll be the negative 60 over 85. And where this changed to plus, we'll have a plus, a negative, so it really will be minus the 24/85. Which means we're going to get about as close to negative 1 as you could ever get. We'll get negative 84 over 85. And that should be the answer to what the cosine of a difference is. What'd you say? You don't believe me? Okay, that's fine. It's your prerogative. Just bring back the calculator. Don't forget it's still storing all the values I wanted it to store. Move it over there. So where are you, buddy? There you are. So we'll clear this out. We'll ask it very politely to give us the cosine of a minus b this time. Now, I hope you guys can see this in the video. For me it looks quite small, but I think we'll be okay. Anyway, so I'm getting that. That looks really close to negative 1, does it? Looks like it might just be the exact same thing as negative 84/85. And it is. So there you go. There again is just sort of a quick verification that yes, we did it right. Okay. You know, for no other reason than peace of mind. I don't know. And to give you another little insight into what the hell's going on here. So moving on. We just did 2. That was the first one. Yikes. I can go faster on the rest. Hopefully. Let's go do 4. So here's 3. Not doing it. So here's 4. We'll do it. Although my heart tells me that I think I did 4 in class, so maybe it's a waste of time, but I'll do it. There's some people watching who missed class or aren't even in my class. Shout out to you, semester 1 kids. Let's do this, and let's do it as fast as we can. I don't want to cut any corners, but let's do it quickly. So for A, angle A, our values of x, y, and r should be, well, they gave us cosine, and cosine is x over r. So we know we've got a negative 15 for x. We know we've got a 17 for r. Again, I know that x is negative because you can't give the negative to the radius. The radius is always positive. So it must have been the x that was negative. And then lo and behold, angle A is in quadrant 2 again. So confirmation. X is definitely negative. We also know that y is positive. We also know that there's an 8, 15, 17 Pythagorean triple. So there you go. There's your x, y's, and r's. Without drawing a diagram, I could draw a diagram if you guys wanted me to, but maybe at this point we don't need it. I don't know. Let's do B. For angle B, our x, y, and r are going to be, they gave us sine. So sine is y over r. So that's a 4 and a 5. And the y has to be positive because, again, the r can't be negative. So it's not like this was a negative 4 with a negative 5 becoming a positive 4/5. It's just got to be. And again, we do have this information. We know that we're in quadrant 2 again. So it does make sense for y to be positive. But x is going to be negative, and it's also going to be 3 from our 3, 4, 5 Pythagorean triple. So there's all 3 of those. So this one now is a little different because we're doing tangent. So we're doing tangent of A. Yeah, you know what? I'm going to just go ahead and start expanding. So the expansion of this is tangent of A plus tangent of B. All over 1 minus tangent of A times tangent of B. And I've got all those values because now that I've got my x, y, and r, we know that tangent is just y over x. So for A, it's going to be negative 8/15. We know that for b it's going to be negative 4/3. In the denominator we'll have 1 minus negative 8/15 times negative 4/3. But there you go. There's your whole expression in lavender. Now we just have to evaluate it. So, sure, green works. So in green, I do need a common denominator for this, so I better multiply by 5/5. And so I'm now doing negative 8 plus negative 45. So that's 53. Yeah, so negative 53/15. Now in the denominator, starting with this, we're multiplying, so we don't need a common denominator. This is an 8 and a 4. I know that looks like a 9, but that's that same glitch that we keep seeing. That's not a 9, that's a 4. So 8 times 4 is 32. So we're doing 32/45. But then we've got this 1. Remember that 1 is a 1/1. So, I got ahead of myself. That 1 is 1/1. So if you need a common denominator with the 45, then multiply by 45/45. And just re-express the 1 as 45/45. We're doing subtraction. So it looks like we have a negative 53/15 over 13 45. So there's our answer as a complex fraction, but you can't have complex fractions. We got to clean this up. All right, I'm going to take all that, maybe shrink it a smidge. So finally, to evaluate this, I would just keep the numerator, negative 53/15. And if you're dividing by this fraction, then you're really just multiplying by the reciprocal instead. So this is our answer, negative 53/15 times 45/13. Again, you should recognize that along this diagonal, we can actually cross-reduce a factor of 15. So dividing this 15 by 15 would just leave a factor of 1. Dividing this by 15 leaves a factor of 3. The 13 and the 53 pretty obviously cannot be reduced any further. So 53 times 3, negative 159.